Okay, so how do we take this knowledge of what we learned in the last opener, just as a review that the first number, in my factoring times the second number gives me my A, the last two gives me my C, and some product, sum, where you're multiplying S times K and adding it to H times R, how does that help me determine my B value? So some people learned it. I mean, there are multiple ways of learning this, and I'm going to sort of show you the sort of most brute force way and then the way that you're going to see consistently through your high school experience. So most people say, okay, well, the first two numbers need to multiply to 2x squared. So I know that has to be 2x times x. And now I'm looking for multiples of 21. And I know the multiples of 21 are 21 and 1. Again, I'm looking for negative 17, so some of you have sort of, oh, well, those both have to be negative to get to negative. Two positives won't ever add to a negative. So there's that, and there is, what else? 3 and 7. Negative 3, negative 7. And what else goes into 21? Let's see. Does 2? No. Does 3? Well, yeah. 4? No. 5? No. 6? No. So it appears like, wait, I'm not going to get to my negative 17. But that's not really what you're looking for. Okay, so you just need to list all the factors, and these are the ones. And some people go, okay, now I need to just try them. And there's more and less intelligent ways of trying them, but ultimately, you not only have to try them, but you have to try them in different places. And maybe one way to think of it is, not only do I need to do negative 21 and negative 1, but I need to do negative 1 and negative 21. And I need to do negative 3 and negative 7. Okay, because where they appear matters. So I'm going to try it. Let's try it. So the first thing I'm going to try is 2x minus 21, x minus 1. The second thing I'm going to try, by the way, I would try it before I tried the second thing, but just to lay it out, 2x minus 7, x minus 3. Hopefully I get it before I try everything I need to try, but keep going. I need to then try 2x minus 1 and x minus 21, right? You notice how these two are different. They have the same numbers, but now the placement of where they are matters because you have a different s and r value, right? They're both not 1 anymore. And then the last thing I try is 2x minus 3, x minus 7. Now some people might look at this and say, okay, I can kind of picture 2 times negative 1 and negative 21 times x, and that is probably not going to add up to negative 17. Right? I don't know if you can see that or not. Right? Negative 21 times x plus negative 2, or 2 times negative 1 is negative 23. So that gives me a negative 23 in the middle. This gives me a negative 13, because 2 times negative 3 is 6, minus 7. This is going to give me a negative 43. And do it out if you don't see it, that's fine. This is going to give me a negative 17. Of course, my last choice is the 1. And I would tell you that this method is painful. It works, sure, you could come down and find an answer. Let's do that. So this is 2x minus 3 and x minus 7, and that's factored completely. But I would argue there's a better way. Certainly a more procedural way, one that's more consistent, one that you could determine for sure. So here's how you do it. You try to find numbers that are the product of A and C. So product of A and C is 42. Positive 42. So what are all the factors of 42? 42, let's see, 1 and 42. I need a negative again still, right? Because I'm still trying to add to negative 17. So negative and negative, negative 2, negative 21. Negative 3, negative 1, 14. 4, no, 5, 6, -6, -7. So adding across, do they add to -17? No. No. Yes. No. So this is my combo. Now the question is, what do I do? I don't just plug it in, right? I am not just plugging in -3 here and -14 here. Okay, that doesn't even work, right? As we found out from before, where we knew the answer to be. Sorry, didn't mean to jump around. Let me go back. I hit the wrong button. Yes. Okay. So we knew this was the solution. So what do we do with the -3 and the -14? Here's what we do. We take our original. We say 2x squared minus 3x minus 14x plus 21. So I have grouped them. I've put them, or I've split apart the -17. And now I'm going to try to group them. There's a couple ways you could group them. The first way, let's try 2 ways and see if we can find a logical method of figuring out which one we want to do. We could put those 2 together, and we could put these 2 together. So let's do that. And we're going to factor something out. So I know that this is an x has in common. So this is x times 2x minus 3 plus factoring out, what does -14x and 21 have in common? Well, 7. And in fact it has, I could do -7. Now you might say +7. Fine. Let's do +7. See where we go there. And this now, with +7, comes out to be -2x plus 3. Well, I can't factor any further, and I can't undistribute any further. And if you want to look at this geometrically, this is x times 2x minus 3. And this one is 7 times -2x plus 3. Hopefully you notice, maybe you don't, that if I factored out a -1, right, if I made this a -7, this would become positive, this one would become negative, and now geometrically I have 2 items with the same lengths here. And so when they have the same lengths there, I can align them. I can basically put them like this and call it, I wish I was a better drawer, call it a rectangle, which is x minus 7 by 2x minus 3. And this is known as factor by grouping. Now you might notice, I'm going to erase, so if you go backwards if you need to see what I did. You might notice that there's a different way we could have grouped them, and probably a more efficient way. We could have put 2x squared minus 14x together. Maybe not more efficient, but another way. We could have done -3x plus 21. I think actually we'd end up in the same problem if you need to see that you could factor out that negative. But factoring this, I would factor out a 2x, and this is x minus 7. And here I could factor out a -3, x minus 7. And the goal here is to get the same in the parentheses, right? So as you're factoring the second one, figure out what do I need to do, what do I need to factor out to get the same thing in the parentheses. So here now I have a 2x and a -3. So those can go together because they're both being multiplied to get x minus 7. Now you might be lost on how am I collecting these? Well, think about what happens when I distribute. When I distribute, I'm multiplying 2x times x minus 7, really. And then I'm multiplying the -3 times the x minus 7. That's really what this distribution is all about. And you see that's the same as that. So if I have two things multiplied by the same thing being added or subtracted to each other, it's the same as if I'm undistributing. I'm collecting them. So that's your solution. And let's get some more practice. I know this is going to seem like a very funky dance, and some of you are going to be tempted to say, I just don't get it. Okay, don't be tempted yet. You need to do the dance for a little while before you can say you totally don't get something. Alright, so let's try the second one. Two things that multiply to a and c. So negative, let me shrink down my work above. Two things that multiply to negative 15 that add to negative 14. So some of you might see that right away, that is negative 15 and 1. So I'm going to break negative 14 into minus 15x, negative 14x, minus 15x, and plus 1x, since those still add up to negative 14x. And now I can collect. I can collect things and group them and factor out by the grouping. So this becomes 3x squared, and negative 15x have 3x in common. So this becomes x minus 5. Plus, I can factor out a 1 here. That's all that they have in common. And this is x minus 5 as well. And so then this factors to 3x plus 1 times x minus 5. And that's now factored. So you can see if you can group them, and you can factor from there and factor out things that give you the same items in the parentheses. Then you can collect them, you can group them, and it gives you solutions reasonably easy. Okay, this is probably one of the tougher items in the chapter, as well as completing the square. Okay, so this is going to require a lot of practice. There's sections in the book. It probably wouldn't hurt to do more problems than what's assigned if you're struggling with this.